a very warm welcome. I'm Mariam from Data is Good, working as a data science evangelist. So at Data is Good, we have trained thousands and thousands of students in our live classes and helped them make successful data science careers. If you are new here, then please do not forget to subscribe to our channel and press the bell icon so that you get all the updates, new content, and do not miss out on anything. In this video, we are going to learn the most important topic of inferential statistics, and that is the Central Limit Theorem. The Central Limit Theorem states that the distribution of a sample variable approximates a normal distribution, that is a bell curve. As the sample size becomes larger, assuming that all samples are identical in size and regardless of the population's actual distribution shape. So in simple words, Central Limit Theorem is an approximation that you can use when the population that you are studying is really big or really large. It would take a long time to gather data about each individual that is part of it. An essential component of the Central Limit Theorem is that the average of your sample means will be the population mean. In other words, add up the means from all of your samples, find the average, and that average will be your actual population mean. Similarly, if you find the average of all of the standard deviations in your sample, you will find the actual standard deviation for your population. It is a pretty useful phenomenon that can help accurately predict characteristics of a population. Let us look at the statement of the Central Limit Theorem. The statement of the Central Limit Theorem is: the Central Limit Theorem states that whenever a random sample of size n is taken from any distribution with mean and variance, then the sample mean will be approximately normally distributed with mean and variance. The larger the value of the sample size, the better the approximation to the normal. The assumptions of Central Limit Theorem are: the sample should be drawn randomly following the condition of randomization. The samples drawn should be independent of each other. They should not influence the other samples. When sampling is done without replacement, sample size should not exceed 10% of the total population. The sample size should be sufficiently large. Now let us look at the properties of Central Limit Theorem. So the Central Limit Theorem says that for any kind of data, provided a high number of samples have been taken, the properties that hold true are: sampling distribution's mean is equal to the population mean, that is, x bar is equal to mu. The standard deviation of sampling distribution, which is also called as standard error, is equal to sigma divided by under root of n. In simple words, standard error is equal to the population standard deviation divided by the under root of the sample size. The sampling distribution becomes the normal distribution for n greater than 30. Let us look at the formula of the Central Limit Theorem. You can see the formula of the Central Limit Theorem on your screen. Central Limit Theorem for sample means is given by z equal to x bar minus mu divided by sigma divided by the under root of n. Here x bar is the population mean, mu is the sample mean, sigma is the population standard deviation, and n is the sample size. This formula of Central Limit Theorem is used to find the z-score. Now let us look at an example. The record of weights of female population follows normal distribution. Its mean and standard deviation are 65 kgs and 14 kg respectively. If a researcher considers the records of 50 females, then what would be the standard deviation of the chosen sample? In this problem, we have the mean of the population, that is mu, equaling to 65 kgs. The standard deviation of the population, that is sigma, is equal to 14 kg. And the sample size, that is n, is equal to 50. As we know, in the central limit theorem, the standard deviation of sample is equal to sigma divided by under root of n. By substituting the values in the formula, we get standard deviation is equal to 14 divided by under root of 50, which is equal to 1.97. So the standard deviation of the sample is 1.97. Now we will look at the practical significance of the central limit theorem. The central limit theorem can be applied to a variety of real-life problems. Now, one of the most common applications of CLT is in election polls, to calculate the percentage of persons supporting a candidate, which are seen on news as confidence intervals. Central limit theorem is also used to measure the mean or average family income of a family in a particular region using the confidence interval. So I hope that you have understood the central limit theorem properly. If you guys have any doubts or any clarification is required, then please do let us know in the comment section down below. Our Data is Good team is always ready to help you out. In case you have any suggestions or feedback, then please do let us know that as well in the comment section. And we will try our best to revert to you and implement them at the earliest if possible. Well, that is all for now. I will see you very soon in another video with yet another interesting topic. Also, do subscribe to our YouTube channel if you haven't already. Bye. Take care.